Hi sir, myself Anand Kumar. I am pursuing 8th sem Mechanical Engineering in C section. Today I am going to do a seminar on the topic of failure analysis of mechanical components. There is a lot of importance given for the mechanical components in the machineries as well as industries or any other worldwide services. These are the outline of my topic. Introduction to failure analysis. The definition of failure is the inability of a component, machine or process to function properly. Failure analysis is the process of collecting and analyzing data to determine the cause of the failure. Then these data and analysis is used to determine the corrective actions. Why failure analysis required? Failure of engineering components frequently leads to disruption in services to the public at large. To avoid the occurrence of the failure of engineering components during services, it is important that whenever failure occurs, the same is thoroughly investigated to establish the primary factor and other important that led to failure, so that suitable recommendations can be made to avoid the failure in future. The failure analysis is main funda is to avoid the failure in futures by knowing the objectives of failure analysis. Failure prevention is the main objective of the failure analysis, because prevention is the better than the cure. Without it, we could make the same mistake over and over without realizing why we are mistaken. Second objective is the planning future projects. Failure analysis is the perfect way to become a better planning projects before you commit time materials. Causes of failures. The probable causes of mechanical components is given: misuse, assembly error, manufacturing defects, fastener failures, design error, improper heat treatment conditions, inadequate quality assurance, casting discontinuities. Methods of analysis. There are some methods for analyzing the failure. Description of the failure situations, visual examination, chemical analysis, metallographic examination, factorography, ADS analysis, evaluation of mechanical properties, non-destructive testings, conclusion and suggestions. Description of the failure situation is to describe the failure situation by service history, records and operations which are abnormal. This information is taken for the analysis. Visual inspection. This is nothing but a eye contact inspection which we can see physically. Examine the failed component for obvious failure features. We can see the locating the fracture breakage along the component. Crack marks, breach lines are noted. Chemical analysis is established for the material for a particular operations which was suitable for that particular operations. Metallographic examination. These are conducted in two steps. Firstly, microscopic examination done by taking components fractures images at lower magnification up to 50x. It gives the information like cracks, originate and propagate regions, and non-metallic inclusions also analysis using optical microscopy. Microstructure analysis can predict the behavior of a component made of particular material. Fractography and ADS analysis. Fractography means it gives the brief information of pictorial representation of a various defects leading to fracture of a metal, including laps, seams, cold shards, cracks, inclusion, porosity, stress corrosion, cracking present on a fractured surface. Common fracture types of are explained below, which we can analyze by using fractography. Ductile fracture, brittle fracture, and fatigue failure. All are different fracture surface. EDS nothing but a energy dispersive spectroscopy. In this analysis, the electron beam is exposed to the fractured surface, and these electron beams and ejected from the fractured surface are electrons are collected using detectors, and these detectors help to find the element present on the surface for a failed samples. From this we can get inclusions entrapment present in the fractured surface. Evaluation of mechanical properties. Components having a desired set of mechanical properties. These properties tells us the behavior of material. Comparison between the fractured region and the way from fracture can give the evidence of fractions. Properties come correlated with the microstructure of material. Non-destructive testing. Once we get the samples from the fractured location of the component, either these samples are from near to the fractured region or away from the fractures are conducted. In NDT testing, to find out if any discontinuity is present in the failed component, even the discontinuity is present in the way from defect is also component problem. Conclusion and suggestions. By compiling the collected information and tested results, we can find the abnormality happened during the process or material is not suitable for particular operation. In this shows the one example taken for the failure analysis, which was reported of the axle shaft of forklift, which is used more in industries. This is the visual inspection. Chemical analysis, that is the fractured surface chemistry and the specification of the given component. Fractography, as inclusions are shown in the structures. Microstructure analysis, which are case hardening has the separate microstructure and the normal heat treated surface has the different microstructure. EDS analysis, that is the sulfide inclusions and the manganese inclusions could have on the surface of the failure. Mechanical properties. Hardness profile. This graph shows that the irregular hardness of the component. Conclusion. The analysis suggests that the fracture initiated from the martensitic case as brittle mode due to improper heat treatment process or high hardness. Moreover, the inclusions along the hot working direction, that is in the longitudinal axis, made the component more susceptible to failure. References are taken from some authors and taking help of the Department of Research and Development of JSW Steel Limited. Thank you, sir.